Well, good morning, my algebras. Here we are looking at the final study guide. And this is the one that is the same kind of size as the actual final. You'll have 34 questions that look like these, and then you'll have 6 no calculator questions. As you can tell, I am not there today because I am not well. Anyway, just had to get through the week and need to get better. So number 1, I can see that the solution of I have to solve for the solution of the equation. I go ahead and I use my SADMAP to isolate my variable, right? So I add 21 to both sides and then I divide by 3, getting x is 9. If this is a one and only solution, right? The only solution that fits for this equation is 9. Number 2, it asks me to write the expression. So when it says 5 times anything that's going to be combined over here, I know that it's going to be combined to a family, because if I have a variable that's added or subtracted to anything else, it's a family where we have to use the distributive property. So 5 times everybody, the x plus the 4. Now sometimes we get confused of where does the plus sign go. In this case it was a sum, but if it was a subtraction or less than, it replaces the word and, right? So that we want to be really clear on that. Number 3, it's just basically reminding myself that domain is the x values and range is the y values. And I list those out. Notice that I don't need to repeat anything. So there's 2 3s in the x value, which tells me 1, it's not a function. And 2, I don't need to repeat those. I just need to say them once. On number 4, we're setting up a proportion. And just to remind you, the concept, the reason why we can use a proportion is because if I have equivalent things, like 1/2 is equal to 2/4, I know that if I use cross products, multiply across the equal sign, I get 4 equals 4. Because of this concept, I know that if I have a missing value here, like this is x and I don't know what it is, I could still solve for the right thing, because when I use my cross products, I'd get 2x equals 4, and I could isolate that variable and solve for the solution, which I know it is 2, right? So because of this concept, we can write these things called proportions, and proportions are equivalent fractions. So we have to break down what it's asking us to. The building is 30 feet tall and casts a shadow of 40 feet. So I know the proportion I'm writing here is the height over shadow, or I could do shadow over height, it doesn't matter. And then I have 2 things that are proportionately written together. I have the building and the tree. I know the height of the building and the height of the shadow of that building. And at the same time, which matters, we don't know the height of the tree, but we do know the height of the shadow. And then I solve this using cross products. I multiply across here and I get 40x, and I multiply here and I get 360, and then I divide by 40 to solve for my variable. And I know that the tree is 9 feet tall. This concept we use several times in different ways, so we'll hit this one again. Number 5, we substitute in for each one of these values. We're saying that m is -4 and v is 8, so -4 times 8 is -32. And then 8 divided by -4 is -2. And -4 minus or subtracting 8 is -12. And -4 plus 8 is just 4, right? Sometimes on the final, we're asked to use words to explain what we're doing here, because the more we use words, the more we can explain how to do something, so we can apply it to any situation. So we're using inverse operations to isolate the variable. So the first step is adding 8 to both sides because it's a -8, and that's the inverse is opposite of subtraction is adding. And the second step is dividing by 4. On number 7, we needed to substitute each point to see if this is a solution to this equation for each point. And in this case, none of these points worked, but we got a good practice in how to substitute and evaluate, right? Seeing if something's true or false. And these were all false. On the final, you won't have one that they're all false, so just keep in mind you're going to have to find that solution. Number 8 is a review of Chapter 5, word problems. And on this one, we always write one on cost and one on quantity, right? One on cost and one on quantity. On here, you could see that Coach Rigby is buying pants that cost $30 and hats that cost $15, and he spent a total of the cost of $750. So this whole equation was written on cost. Then we do one on quantity, and it tells us that he is buying a total of 30 items. We already know that he's buying pants and hats for 30 items total. And then I chose to solve this using elimination. The tricky part is I chose to eliminate the hat, so I need to multiply the entire equation to make it an equivalent equation by -15. So I can eliminate the hats and solve for the pants. Once I know the pants are 20, I know that the hats must be 10 because there's a total of 30 items. Number 9, if we are given a point and another point, and we have to write the equation of the line, I want to get to use the point slope form, which is y minus y1 equals slope times x minus x1. But first I need to have this little guy here, the slope. So I use my slope formula to solve for the slope. Once I have the slope, I can pick a point. I chose to pick the first point because I knew I was going to have a fraction with 5 in it, and I also had 5 in it, so I knew it would probably work out pretty well for me. So I go ahead and substitute that in, and I solve, right? So my final equation, I have to distribute here, so that's how I get 5/7 x plus 25 over 7, and then I have to add 3 to both sides. Now, this reminds me of how to add my fractions, which will be a part of our no calculator part. So let me just remind you of how to do this. If I have 25/7 and I'm adding 3 to that, this is 3 over 1. So to get a common denominator, I'm going to multiply this equation by 7. So I get 21 over 7, and then I simply add the top numbers. 25 and 21 is 46, and I can keep this as fraction form. Over 7. On number 10, it asks what's the slope of the line, and the slope using our y equals mx plus b. The m value in front of the x, not including the x, is the slope. Number 11, what's the x-intercept? We know that if something is an intercept, whether it's an x-intercept, the y value is 0, or if it's a y-intercept, the x value is 0. We know that if we're eliminating one of these because the value is 0, we can just simply solve for the x value, dividing everything by 2, right? If this question asks us to solve for the y, then we would make the x 0, and we would have divided by 6. Okay, on number 12, it asks us to find the parallel and perpendicular slopes. So first we identify the slope here, and the slope here is -5. And for parallel lines, they have the same slope, right? Because they have the same rise over run. That's why they never collide. With perpendicular lines, they cross over at exactly 90 degrees. So because of that, they are the opposite. So from positive to negative, in this case, from negative to positive. And we have the reciprocal, right? Or I like to say the reflipical. So we have to flip over the fraction. On number 13, we need to see which one matches this scenario. On the first one, we know it doesn't grow rapidly, so this one's out. On the second one, it grows slowly at first, and then it grew faster. You can see it did grow faster, and then with fertilizer, and then it was trimmed. So boom, it got cut, right? And then the other ones work. On 14, this is a throwback to chapter 1. We first distribute. I have to evaluate my expression using PEMDAS. I do that first. And then I have to solve using SADMAP. I go backwards to isolate my variable. And we use this for the rest of the whole semester, right? We're always solving for a variable using this format. We evaluate first, and then we solve. Number 15, it gives us a point and asks for a perpendicular line to this line. So we know we have to have a perpendicular slope. And once I have a point and a slope, I use the point slope form, which is y minus y1 equals slope times x minus x1. And I substitute in my slope and my point, and I isolate the variable, finding the new equation. On number 16, I'm solving using either substitution or elimination, but for me this is in standard form where I have ax plus by equals c. So I'm going to use elimination because I feel like it's faster. Because these are already opposite, I'm going to go ahead and multiply 2 to the whole bottom equation, so that way I can eliminate right here. Right, I can cross out these x's, and now I can solve for y. Once I solve for y, I substitute back into either one, this equation or this equation, in order to solve for x. And then I write it as a point because it is a solution on a line. On 17, this is another proportion question. As soon as it says that y varies directly with x, we're saying that y is proportional to x. And we know that our slope is always y over x. So we keep it in that format, right? If I know that y is 15 when x is 6, what will y be when x is 14? And I can just use my cross products to get 6y equals 210, and then I isolate the variable, solving for y. On 18, how do I know this is a linear function, not just a function? We know it's a function because x doesn't repeat or cheat, but is it a linear function? Well, we have to see if it's a constant change in the x and y values. We can see it's added 2 every time in the x, so that works. And it also happens to be added by 2 in the y, so it also works. So yes, it's a linear function because there's a constant change in both x and y values. On 19, because it says if this is true, what would this be? Well, in order to know what this is, we'd have to know what x is. So we go back and we solve for x here, simply dividing by 2, and then we substitute that value in to solve for evaluating this expression when x is 5. On 20, we're just solving for a variable, and it could be a multitude of variables that we're asked to solve for, but in this scenario, it's asking to solve for c. I use my SADMAP to isolate the variable, right? That's all I need to do here. So in order to solve for c, it can't be part of a fraction. So I multiply both sides by c, so it's no longer a fraction, right? Then I have c a equals 2b. Now, because I'm solving for c, I simply need to isolate c dividing by a on both sides. And then I get c equals 2b over a. On number 21, again, we see this proportion popping up. And so this concept here, it's written as a proportion. It tells us that it is. So we use our cross products. And in this case, because it's a variable subtracted by something, we have to know that's a family, and we have to distribute, getting 2x minus 18. Then we do our cross products on the other side, and x times 4 is just 4x. And now we can isolate our variable using SADMAP. Okay, on number 22, we have to see if this is a function, and all we're looking for is the x values. If the x values repeat, which they do, then no, this isn't a function because it's the x value has more than one y value. If it didn't repeat, yes, it would be a function. On 23, we're asked to solve by graphing. I graphed the first equation in red because my y-intercept is -3 and my slope is going up 2 and over 1. I put that point in several times so that I can really check to make sure where it's going to collide. I draw my line using a ruler and include my arrows. On the next equation, I know that my y-intercept is 1 and my slope is up 1 over 1. So I'm just going up 1 over 1 each time, and I keep going to see where these two lines will collide. Put my arrows in, and then where they collide, this point right here happens to be 4, 5, and so that's why it's the solution. On 24, I'm just graphing the line. My y-intercept is 3, and my slope is a negative 2/3. So I know that can be negative 2 over 3 or 2 over negative 3, right? So if I do the first one, I would go down 2 and over 3. And if I do the second one, I'd go up 2 and over -3. It really doesn't matter which way we apply the negative, just that we only apply it to 1. And we could tell that this is a negative line because it ends in negative infinity, right? Oops, sorry about that. It ends in negative infinity. If it's a positive line, positive slope, it has to end in positive infinity. Just something to check your work with. On this one, it says we have a slope of 4 and a point of -2/5. Again, we're asked to use this point slope form, right? Y minus y1 equals my slope times x minus x1. Now, I know some of you guys have been using y equals mx plus b and plugging in a point and the slope and solving for b, but often you forget to rewrite the equation correctly. So I really want you to learn how to use this. Not only that, but it prepares you for Algebra 2 in H and K, which we'll talk about that in Algebra 2. 26. So this one I can solve. It's obviously set up to solve using substitution because it tells me what y equals. So I can substitute that into the y of the other equation. And when I do that, I can see that the x values eliminate and I end up with 4 equals 2. Well, that's not true. And not we don't base solutions on lies. So we know that this is a no solution, right? Just like real life. Okay, on 27, we're writing the rule. How do we write the rule? Why? I look at the y values first because I want to find the slope right here. And I'm checking to see what that is. And I can see this goes up by 2 every time, right? So that means that the slope is going up 2. I multiply that by the x value and I see what happens to get to the y-intercept. So 2 times 1 is 2, right? And what do I have to do to get to 5? Well, I have to add 3. And so I know adding 3 is what happens. And I can go ahead and check this for the other ones to see if it's true, if I'm a little curious. So if I multiply 3 by 2 and add 3, do I get 9? I do. So I know I'm writing the rule right. On 28, it gives me a function right here. And it says, what if the f of x, what if x equals -3? What would the y value be? So I substitute that in to the equation, and I see that y will equal -26 when x is -3. And I write the point like this. All right, writing these linear equations, we started these all the way back in chapter 1, but writing them as functions, we did that in chapter 3 and 4 and again in 5. So we're looking at a local gym is offering a membership cost. It costs $60 to join. That is going to be our y-intercept because the initial fee is $60, right? And that's where you put that initial fee right here. Monthly, per month, is what it's going to go up, or it's going to rise and run, or it's our slope, and it goes up by $15 a month, right? So we could write the function like this, or we could write it what it is. We could say the cost equals $15 a month plus that initial fee of $60. This might make more sense for you, but you decide how you want to write it. Either way, these functions are written correctly, because when I go to graph this equation, I don't need any of the negative values because we're not going to do that. But I would know that the cost would be the y, which is why we could put y as the cost. And the months, because it changes per month, would be the x value, which is why months goes here. And then obviously this would start at $60 and then would go up $15 a month, right? So very much a linear equation. Okay, then on the second part of this is asking what happens after 2 years. Well, we know that 2 years is how many months? 24 months. So we substitute 24 for the months and evaluate that in the cost in 24 months would be $420, right? 30, we have Jess and Darnell are saving up to buy cars. And on these equations, this could be a inequality, or this is just when they're the same, but we know that we can write these out. So let me just get to the right color here. Okay, so Jesse in this light blue color here, he has $3,500 and he's going to save $500 a month, right? So we write that equation here. This represents Jesse. And then Darnell in the purple, has $2,400 and he's saving up $600 a month, right? So they have very different starting points, but Darnell's going to save a little bit more per month, right? So that means at some point they'll catch up. And on this equation is asking when they have the same amount, when will they have and how many months? So, and how much will they have, right? And how much, so there's two parts to this question. So I know I can write this to be when they are the same, so it's equal. Now, if it was one had the other, let's say if Jesse had more, I'd write it like this. But if Darnell had more, when it would be like this, right? So we know we could do that multiple different ways. So we solve for our variable, finding out that in 11 months, they will have the same. But how much? Don't forget the how much will they have. So we could either substitute in for here, so 2,400 plus 600 times 11, right? So I don't have a calculator, so I'm just gonna so 2,400 plus 6,600 is going to be $9,000, right? And of course, you want to check your amounts with a calculator, right, to make sure you're doing it right. Or we could have done it on the other side, and we would have had 3,500 plus 500 times 11 would be 5,500. And when you add this up, you also get $9,000 because we know that's when they are the same, right? Okay. Also on the final, you'll have 6 no calculator questions. You'll start with that first. On those, you'll have adding and subtracting fractions that do not have common denominators, so you have to take care of that business. And you have to know how to multiply fractions, which are multiplying straight across. And you need to know how to keep, change, flip for dividing fractions. And you also have a couple timetables on there, all right? Note that we made a note card in class, so if you were absent for that, you're probably going to want to, either I wrote you an email already about it, but if I didn't know you were absent today, we did it earlier this week when I was still there. But if you missed this opportunity, you need to come see me either in between a final, or I will be at school at 7 a.m. on the first day of the finals. So I can either review for you there or help you make the note card, because I collect the note cards in class, right? So that I know what's on them and so that I make sure that you have them on the day of your final. And the other things that you would need to know are that I'm here for you. So if you want to meet at 7 also on that Monday morning, or another time, let me know so that I can make sure you're very prepared for the final. Okay, have a great day. Talk to you later.